All right, the lesson on 3.1 and 3.2 is going to start as kind of a refresher for what we knew from Algebra 1 on solving systems. So, if my pen will work, try again. We're going to first solve this system by graphing. And my first line is 2/3 x minus 1. I'm going to do this line in blue. So we're going to start at y-intercept of -1, and then slope of up 2, right 3 units. Now, normally I'd do a much more careful job of graphing if I was doing this by hand. However, I'm not going to do a great job because I'm on a tablet. My next line I'm going to do in red, 2x plus 3, means we started a y-intercept of 3. Normally I'd shift up 2 and right 1, but I could also shift down 2 and left 1. And that would still give me a positive slope. And had I done a little better job of graphing, I could see that this red line and this blue line would intersect at the value of, let's see, that's the ordered pair, -3, -3, left 3, down 3. So the solution to this system is always going to come in an ordered pair notation, so -3, -3. So continuing on, this first line I'm going to do in blue. -1 is my slope, my y-intercept. My slope is a -1 over 1. So I'm just going to kind of draw in some points and not connect them, because obviously my connecting abilities are a little rusty right now. There would have been my blue line. My red line is 2x minus 4, so -4, slope of up 2, right 1, and I see right away that the intersection of these lines would be at the ordered pair right 1, down 2. The next system is set up to solve in what we call a substitution method. You'll notice this second equation says y equals -2x plus 2. That means anytime I see a y, I could replace it with a -2x plus 2. And I'm going to do that right here into the top equation. So we're going to start with -3x minus 8, but then instead of y, we just saw that I could replace it with a -2x plus 2. And apparently this equation is going to equal 10. So we're going to distribute and collect like terms. This becomes a plus 16x minus 16 when I distribute. And then when I collect my like terms, I'm going to add the 16 over. Tried to make sure these came out kind of nice, so if you're noticing yours are not coming out nice, try again. Now this is only half the story. X is 2, which means if I go back to this box, the recipe for y, I'm going to be able to figure out what y is, because I know that -2 times the x, which I just found, plus 2 will give me my y. So let's see, -4 plus 2 is -2. My ordered pair is x comma y, or -2, -2. Same idea here for number 4. This time the top equation is ready to substitute into the bottom equation. So we're going to start with -8x minus 3, and then instead of y, got -4x plus 13. Sorry, my writing's a little sloppy today. Equals -23. So we have -8x. This becomes a careful plus 12x. That'd be a -39 equals -23. Combining my like terms, I get 4x. Let's see, if I add 39 over, I'm going a little fast, sorry. If you need to rewind, go ahead and figure it out. I should probably slow down so I don't mess up though. Alright, x is 4. Going back to my box, my recipe for y, it's -4 times the x value plus 13. So let's see, that's -16 plus 13, so my y value must be a -3. And my final answer is the ordered pair, where are we at, 4, -3. Very nice. Okay, moving along. Solving through elimination methods is where when you add them together, you would like your ordered pair to cancel out. One of the variables to cancel out. So when I look at this, I notice the y's, if I could change him to a -9, that would make the y's cancel out. So I'm going to multiply the bottom equation by a 3. And my new system is going to be set up like so. Now, the second equation is a linear combination of the first. So by multiplying everybody by the 3, I'm not affecting the value of the equation into the system. I do see now that the y's will cancel. This leaves me with, let's see, that's a 13x equals 39. So x equals 3. And now I can choose my favorite equation. I'm going to go back to the original, the bottom equation. So 7 times the 3 I just found, minus 3y equals 6. And after a little bit of algebra, I'm going to subtract 21. So let's see, that's negative 15. My y is found out to be a 5. So my ordered pair answer is a 3, 5. One more for good measure. This one's not so exciting because there's not one linear combination on one of the equations that will help me out. So I just have to make a decision if I wanted to eliminate the x's or the y's. I'm going to eliminate the x's today. So I look at a 9 and a 5, and I notice one's already negative, so that's great. But their common multiple that I'm going to use is a 45. So he needs a 5, he needs a 9. That gives me 45x minus 15y equals, oh jeepers, let's see. I should use a calculator so I don't mess this up. I'm sure you remember this from Algebra 1, but if you make one teeny tiny mistake, you're in trouble. So that's a negative 90. Oops. And then negative 45x plus 72y equals 90. Oh, that's interesting. We end up with, let's see, 60, 50, 7y equals 0. If I divide, either way, I get y equals 0. So when I plug that back into my favorite equation, I'm going to use the top equation. I get 9x minus 3 times 0 equals negative 18. So 9x is negative 18, and x is negative 2. So my final answer for ordered pair is negative 2, 0. I'm sorry if that felt a little fast. Please stop here and go back and rewatch them if you need some more refresher on that. However, get this out of there. Okay. This is what I'm really interested in. This is setting up a system with variables, and I am not sure. It depends on how our class is moving along. We may or may not be solving all of these through a method, so what I think I'm going to do is I'm going to solve the first one, and then from then on I'm just going to set them up. The other issue is I only have 8 more minutes to figure this out before I start my next class, so hang with me. Cody and Gabriella each improved their yards by planting hostas and ornamental grass. They bought their supplies from the same store. Cody spent $120 on 10 hostas and 10 bunches of grass. Gabriella did $54 on 5 hostas and 2 bunches of grass. What's the cost of 1 hosta and 1 bunch of ornamental grass? So first thing we need to do is set up our variables, and you could set them up however you want, using whatever variable you want. I'm going to let h represent the hostas. Now, notice the question says, what is the cost? That doesn't mean h represents the number of hostas. H actually represents the cost of 1 hosta. And I'm going to choose G to represent the cost of 1 bunch of grass. I don't really know anything about gardening, so sorry, I don't have a lot of context here. My first setup is going to represent what Cody spent. So he spent $120 on 10 hostas and 10 bunches of grass. That means he bought 10 hostas, 10 bunches of grass, and his total at the register was $120. Now the next setup has to do with Gabriella. 5 hostas and 2 bunches of grass for $54. And that is the setup of the system, and that's actually the hardest part of this problem, is the setting up from words to algebra. Now we're going to take our algebra skills and we're going to go ahead and solve this one to figure out the cost of 1 bunch of grass and 1 hosta. I'm going to use the elimination method as opposed to the other two just because of the way it's set up, and I noticed that if I was to multiply this bottom equation by a negative 2, the h variable will cancel out. So I'm going to rewrite my system with my new linear combination. Gives me a negative 10h minus 4g equals negative 108. So we have 6g equals 12. And apparently g, which represents the bunch of grass, is $2. Now we've got to go back and find the cost of a hosta, so I'm going to use the red equation. 5 hostas plus 2 bunches of grass, which we now know is $2, is $54. So if I solve that, oh, that comes out nice. Remember, these are going to, whoops, it's a 4. These are going to come out really beautiful. A hosta, apparently a pricier item, is going to cost $10. So somewhere in your answer, if I asked you to solve the system fully, you're going to say a hosta costs $10. and a bunch of grass costs $2. It's not exactly a sentence, but it's a very verbal answer for what is really an application problem that someone might actually have to do something similar to that in their life. So the next question, we're just going to set it up. I'm not going to go ahead and solve it, but I might give you a little insight as to how I would solve it if I wanted to. It's possible I might be saying you can solve them for extra credit. I don't know. We'll get creative with this. Elia and Eugene are selling wrapping paper. Customers can buy plain or holiday paper. Elia sold 2 rolls of plain and 8 rolls of holiday, $184. So there's one sentence we're going to set up. Eugene sold 10 rolls of plain and 2 rolls of holiday for $160. And the question is, find the cost of 1 roll of plain and the cost of 1 roll of holiday wrapping. So I need to define my variables first. I'm going to let P represent the cost of 1 plain roll. And then I'm going to let, let's see, H represent the cost of 1 holiday roll. This is a very important part of this question. This is defining your variables. It's something we're going to ask you to do on a quiz. So for Elia, which I'm going to do in blue, she sold 2 plain and 8 holiday for $184. And then in red, Eugene's setup is 10 plain plus 2 holiday equals $160. Now, if I wanted you to take this a step further, I would solve this through elimination, and I don't know, today I decided I want to eliminate the h's. So if this is a positive 8, I can multiply this bottom equation by a negative 4, and that'll create an elimination of the h's. Now, I'm going to stop this problem here for the sake of time, but you, of course, could finish it. They're going to always come out nice for our problems. I made sure that happened. All right, this is pretty much the same question as a couple problems ago. So moving on, let's talk about the school bus problem, because you're going to see this one a lot. We have high school A and high school B going to trips. High school A rented 9 vans, 5 buses for 341 students. High school B rented 2 vans, 10 buses for 458 students. And the question is, find the number of students that a van and a bus can hold. So setting up the variables, pretty lame. So V is going to represent the number of students in a van. And B is going to represent the number of students in a bus, assuming they're to capacity. So setting up our system for high school A, we got 9 vans plus 5 buses, 341 students. And then high school B, 2 vans and 10 buses, 458 students. And again, it's up to you how you want to solve this. Elimination is probably the easiest. I noticed 5 and 10 have an easy multiple that I can figure out of 10, but I need this equation to have a negative. Whoops, that's not what I wanted. Back up. I want it to have a negative 10, so I'm going to have to multiply that equation by a negative 2, and that way I'll be able to solve the system for vans and buses. So let me skip ahead and make sure we're not leaving off any type of problem. Oh, the musical theater question. Real quick. We are selling tickets to a theater, and there's 2 different days the theater was selling tickets. They want to figure out the price of a senior citizen and the price of a child's ticket. So I'm going to use S to represent, I don't usually like to use S's because they look like 5s, but S is the price of a senior citizen ticket, and C is the price of a child ticket. So setting up my system, 3 senior citizens plus 6 children, total $69. And then the second day, $111. 7 seniors and 6 children again. No. 9 children. I need my bifocals on. Alright, if I wanted you to solve this further, there's not a really nice way to get the S's or the C's to cancel out, so I'm going to go with the S's. And I see a common multiple of 7 and 3 is 21, so if I multiply one of them by top by a 7, that means the bottom one is going to have to be multiplied by a negative 3. I'm not going to finish that problem for the sake of time. I literally have 20 seconds, but I hope this was enough to get you going on your 3.2 bookwork. Please come in and ask any questions you have.